You've seen it. So we want to go there. There's a Shackleton crater on the southern part of the moon. This is a very important place because inside this crater there's always shadow. It's always dark. And inside this there's a frozen water. And this water was froze when the solar system was forming. So we have the whole history of the solar system inside this water. And if you have water, you can, of course, use it. And on the moon, there's a lot of helium-3, which can be also used as rocket fuel. So if you create a base on the moon, it could be a very nice fuel station for the future exploration of Mars. Great topic. So yeah, because everyone wants to go to space, and this is how hard it is. So you have to be very multifunctional, because you've seen that this small robot, which is only on the surface of the moon, which has this scoop and this kind of thing, which is creating this bone-like structure, it's autonomous robotics. So you need to know how to do robotics. You need to know how to program this. You need to learn how the engineering is being done. It's also collect the sunlight and has a magnifying glass in order to get the sunlight and heat up the regolith, melt it, and then it's using this this nose or this device in order to create this printing structure. Okay, so there is a long list of topics. I will leave this presentation for you for later reference, but there's a long list of topics that you need to cover during the astronaut training. So in order to prepare as an astronaut, of course, everyone's favorite is flying to space and something like that. But before that, you need to obtain a lot of different knowledge. My first education was in computer science, and then second education was in aerospace engineering. Agatas is a neuroscience scientist, so she's all about brain and all biological processes. And she said that there's a very nice combination of those two in the space environment, and this is right. So there's a lot of different ways how to become an astronaut. Right now, you can be any career path can lead you to be an astronaut. But right now, there are four, the most probable career paths that will give you some more advantage than the others. The first one is, louder, please. Engineering. This is the first one. So yes, engineering is one of the career paths that give you some kind of advantage. The second one? Biology. Science in general. So biology, geology. Because if we are going to send people to the moon, that probably will be biologists, right? If you are going to send geologists, because there's only minerals on the moon. But if you are going to send people to Mars, we are going to send people to look for life science, right? So who are we going to send? Biologists. Especially people who are focused on microbiology, because right now we don't have large animals on Mars, so we will be focusing on microbial life. So this kind of people. And two more. This is a medical doctor, because medical doctor, and it doesn't have to be like medical doctors, but also can be someone who is specializing in this kind of area. And we of course need a pilot or test pilot or something like that. And the best person would be someone who is connecting those all of these fields. Of course, you cannot have all of this knowledge, but you can specialize. For example, you can be a medical doctor and then learn how to fly, learn how to do microbiology research, learn how to engineer stuff. And this is very important. Throughout the whole career of the astronaut, you have this one specialization you were selected with. So for example, in my case, the first education was computer science. So everything which is connected with robotics, algorithm, artificial intelligence, machine learning, this is like my field of expertise. But I also have this aerospace engineering. So all the stuff which is connected with body, and especially I'm specializing in human spaceflight. So everything which is connected with body, spacesuits, operations, extracurricular activities, this kind of idea, right? And you find your niche. And if you have this kind of niche, for sure you will be very good candidate for the astronaut. Okay, the first thing is aerospace engineering. There's a lot of different fields that you need to cover, from rocket science, from space planes, to small capsules. You need to learn how to how to conduct the experiments with materials, different kinds of materials, because of no gravity. There's completely different behavior of different coolant agents and so on. But with the space, with the rocket science, you also have fuel inside your rocket, right? But when there is no gravity, this is how water, and that's also
Marion Kendra suggested that I dip this in a bag, but bags don't hold water.
Yeah, so the same like with water, you have the same effect with your gas, and inside of your engines, inside of your fuel tanks, you have exactly the same effect with your fuel, right? So look what's happening.
Okay, so instead, I fill the water bag. This has drinking water in it.
By the way, do you know this person? It's kind of very well famous astronaut, very well known. Chris Hadfield. He's a Canadian Space Agency astronaut, and he's famous because he sang David Bowie's David Bowie's song "Space Oddity," and it's very famous on the YouTube, and you can find it.
And I'm going to squirt a bunch of water into this washcloth.
I would not dare to leave my mic here.
Okay, so here's a soaking wet washcloth. Get the microphone so you can hear me while I'm talking.
By the way, look at his wristwatch. This is a very nice thing. So,
okay. And now let's start wringing it out. It's really wet. It's becoming a tube of water. The water's all over my hands. In fact, it rings out of the cloth into my hands. And if I let go of the cloth carefully, the water sort of doesn't stick to my hand. Okay, so the experiment worked beautifully. And the answer to the question is, the water squeezes out of the cloth, and then because of the surface tension of the water, it actually runs along the surface of the cloth and then up into my hand, almost like you had Jello on your hands or gel in your hand, and it'll just stay there. Wonderful moisturizer in my hands. And the cloth doesn't really unravel itself. It just stays there floating like a dog's chew toy, soaking up.
Yeah. So this is very nice, right? But there's another effect. Because of no gravity, there's also no air circulation for itself. So you don't have this cycle that hot air is getting up because there is no up, right? There's no gravity because hot air is lighter. And there is no weight in space. Everything has mass, but it doesn't have weight, right? So it doesn't go far up. Imagine if you have flame. Why candles have this kind of shape of flame? Because of the gravity. The gravity shapes this. And there is another also different effect. When you light your candle, it will take some oxygen molecules from around, and it will burn this out. But in space, you don't have this convection, so you don't have this circulation. So the first flame is going in every direction because there's no gravity. And I have a video of that. It's unfortunately it's not very good quality because this experiment was done a long time ago. But yeah, I can show you up. Okay. So
flames certainly need more fuel. Flame bulb, unlike fires, oxygen fires.
So this is a very nice comparison. So because of the gravity, you have this kind of shape of the flame. But in space, you have this different kind of flame.
It's Williams.
Okay.
It's in micrograph. That's right. Burning.
So
The
let's
droplets
see this.
small droplets of heptane were burning inside the flex combustion.
So this is how flames behave in microgravity. This is a one gasoline drop, and they light it, and this is how flames are spreading. So there's a very nice also different effect. So after a while, flames disappear, but this is still burning. is very hot air, because there is no circulation, it's very hot air. And this flame has consumed all the oxygen which is around, right? So it's still burning, but it's like completely disappears. And when it gets, because if you don't have the circulation, you have this kind of air pockets. So it's like bubbles of oxygen and hot temperature and colder temperature. And if you don't have fans, it will be staying in the same place. So you need to make somehow fans to slush it around, right? And then the flame disappears, and after a while, it hits this kind of pocket, it bursts once again. Look at this.
Chamber. As planned, the flames went out, but unexpectedly the droplets of fuel continued burning. That's right, burning without flames, says Williams. At first we didn't believe it ourselves. In fact, Williams believes the flames are there, just too faint to see. These are cool flames, he explains. Ordinary visible fire burns at a high temperature between 2200 and 3100 degrees Fahrenheit. Heptane flame balls on the space station started out in this hot fire regime. But as the flame balls cooled and began to go out, a different kind of burning took over.
Okay, this is very nice, and this is completely different. So it changes all your processes of how rockets behave in space, how your rocket fuel will burn inside of your engine, right? How you will pump, because on Earth is very, you go for the gas station, you fill your tank, and you have small pipe to your engine, and whenever you go, the engine is like sucking all of this fuel, right? And this is because of the gravity. So gravity is pulling the fuel towards the tank, and it's sucking by the pump. But in space, you don't have this kind of things. So you have to think completely different. And this is the rocket science. So you are thinking about different ways how to deal with microgravity and how you engineer the systems that are very well known here, that you have to adjust in space. So, of course, during the astronaut training process, you need to learn how to fly. And this is very important became a pilot. Because astronauts are people who are not risk takers. They do calculated risk, but it's not about being extreme. And nobody wants to fly the aeroplane, like a real aeroplane, commercial jet planes, when the pilot is, we'll do very nice stunts today, this will be very nice, right? And if you are giving you the one and only International Space Station, they don't want people who are, I would say, to the extreme, taking actions that is not very nice. So they want calm people who can deal with dangerous situation with this cold blood and having a lot of knowledge in order to explore and in order to have the information how to deal with any kind of situation that it may encounter. Okay. So there is another effect which is going with flying. So you learn how to make a decision in a very quick manner. And when you take this kind of decision, you have to stick, and this kind of decision may matter, that whether you can die or live, because you have 1 second. And especially this is true while you are flying. This is called low passes. So I had a trainer in my military Air Force Academy. So and he was like, yeah, I'm flying like 900 kilometers an hour, and we're like 50 meters above the ground. So there's like, if you make slight adjustment with my wrist, we're dead. Yeah, because like, if you're flying 900 kilometers, like 50 meters, like, and that's it. So you have to make, and then you have breach, and then you have to react, and your decision can matter life and death. And this is the reason why you need to have people who have full blood, who are very well trained, and who are very well. Basically, they're looking for the astronauts in 4 those kind of areas: scientists, engineers, medical doctors, and test pilots. Of course, if you have experience in more than one area, it will be better for you, right? They will teach you the other areas because it's very important. But your specialization influence the most on all of your process. So every astronaut can have different career, and every astronaut can have different path. So for example, I was engineer, but I had to learn how to do biological experiments, how to work in the laboratory, because right now, International Space Station, it's a huge laboratory. And those days when the astronauts were fighter pilots and this military jockeys, so the people who are like, they have right stuff, already passed. Because right now, we are in this more stable time. So we are looking more into engineers and scientists. So astronauts do not do, they conduct science, they operate the equipment, they conduct the experiments, which was prepared by the scientists here on Earth. So scientists here on Earth are creating the experiments, they are doing stuff, they are creating hardware, they are sending this hardware to space, and the astronauts execute those stuff. So they need to learn. The astronaut training process takes around 2 years. It depends on the space agency, but usually when you are selected as an astronaut, there's a 2 years period of learning everything around, and then this is the time when you are an astronaut candidate, and after that, you're a qualified for flight assignment. And this qualification for flying assignment can take long time. I mean, like, after 2 years, you're an astronaut, you get your astronaut badge, you can call yourself an astronaut, and then you wait for flight assignment. As we know, we have like this half a year tours to the ISS, and there's a lot of astronauts waiting for this, and everybody wants to fly and so on. So it can take up to a couple of years when you are flying. And the most time, there was one astronaut, Bruce McCandless, and for sure you have seen this person, but you probably don't know his name. He was the person who was flying this jetpack outside of the space shuttle in front of the Earth, right? So basically, he waited like couple of years to fly to space. But usually it's a couple of years. It's like 5, 6, 7 years after you finish. But what we are doing in this time? You are speaking in public occasions, you are educating people, you are trying to learn yourself, you are helping the other engineers how to create a cockpit layout, how to fly the spacecraft, you are testing the new equipment, you are testing the new stuff, you are testing the new tools, you are doing a lot of research, biological research and engineering research, and you of course support the other missions which are there. So I also needed to learn how to do chemical stuff, because this is completely out of my scope. So there's a very nice thing. Remember this Moon Village project? This is this regolith structure, bone-like shape, and this is in Aztec in the Netherlands, where I was working together with Agatha on this kind of stuff. Okay, you need also education. So you go back to school. Like literally, during this astronaut candidacy, you have like around two years, and the classes looks exactly like university. So there are desks, there are seats, and there's a professor who is teaching you geology, geophysics, biology, chemistry, computer science, programming, robotics, aviation theory, and there's hundreds of physics, and there's hundreds of different topics and fields. It's like completely like university. You're sitting there for 8 hours, 9 hours a day, and you are just learning and learning. And you have, of course, you have to learn English and Russian. English is not my first language, and Russian is also not my first language. So for me, it's just like learning two another languages, right? So for me, it's easier because Polish is kind of similar, like 40% is kind of similar to Russian, and I started my English a little earlier, so I have a couple of more steps in front of my colleagues, right? So you have like 1,000 hours of Russian, and a lot of astronauts is saying that this is the hardest part of the astronaut training, because Russian grammar is very hard. Why you are learning Russian? Because right now, as we speak, the only way how to get to space on the ISS is only with Russian from Kazakhstan, from Baikonur. So, and half of the ISS, there are two languages which is currently spoken on the ISS, which is English and Russian. And there's a lot of communication, there's everything which is connected with the rocket science, orbital mechanics, and so on, is taught in Russian. So you have to learn Russian. You have this 1,000 hours of Russian before you are going to Moscow, and then you start learning rocket science, spacecraft design, spacecraft operations, emergency situation, everything which is in Russian. Yeah, so you have to pretty understand this language, right? Okay, let's go further. Engineering. This is one of the best and most important parts of the training course because, of course, you are going to be an engineer in space, right? Because there's a lot of different kind of robotics. There's a hundred of different ways how you can destroy your spacecraft, and of course you have to maintain the spacecraft. Because astronauts on the ISS, they are making like every week they are making around 40 hours of science and 60 hours of maintenance of the ISS. By maintenance, I also mean cleaning the toilet, because everybody forgets about that. But cleaning the toilet is not, I would say, very easy, because imagine the situation that the toilet needs to work in the microgravity. So everything that you do, it also needs to be working in microgravity. So it's very hard to grasp on the concept how it's working, and of course it's very hard to maintain. And it has a lot of mechanical components which breaks down constantly, especially American. Because we have two toilets, one is Russian and one is American, and this American is like constantly breaking. Okay. So there's you have to of course learn how to do geology and planetary science. Why is that? Because if we are going to send someone to the moon or Mars, we are going to send someone to study rocks. But there's another effect. It's not only about sending people to the moon and Mars and that's it. That's very nice. Good that you were on Mars. Good for you, right? It's not about that. And the same applies to the ISS. So NASA has this very nice slogan. It says, of the Earth, for the Earth. And there's a lot of things which came to you later on as spin-off projects. So for example, you're living in Delhi, right? It's very nice. But for me, this is a completely different environment. So I'm constantly using my map application on my mobile phone. A couple of years before, like 10 or 15 years ago, there was no such thing. I would be completely lost in this place, and I would have to trust some people who guided me. Right now, I take my phone and I'm using the satellite information. So there are satellites around there. So we are constantly, every day, we are using the technology which was developed for the space program, and we have application here. It's only not only satellites, but all of your advanced clothes. Like for example, if you're going mountaineering, there's a lot of advancement in medical processes, in engineering, in combustion, because astronauts in space they are losing sight because they are constantly living in the small confined spaces, so they don't have this they cannot look out the window and see long far away, right? So they have to readjust their eyes, and because of that they're losing sight, like 2 dioptries every 6 months, something like that. So and they're losing this permanently. There's another effect which is called VIP. Because there's no gravity, all of your body fluids is going up. Because you have heart here, right? So the heart is pumping, and it's pumping more, I would say, with more force. So when you have the eyeball, like that, the fluid is pushing the other side, so it distorts the eyeball. And this is also a problem because it can permanently destroy your eyes. And this brings me to the topic, so what are the requirements for being an astronaut? Of course you need someone who is healthy enough, because if you are going to invest, because you don't have to have money, right? This is not the requirement. So astronauts don't have to be a wealthy person, but you have to excel in whatever area of expertise you choose. You choose engineering, mechanical engineering, stick with mechanical engineer, try to be the best mechanical engineer. Then learn, if you are going to be best mechanical engineer, you will have money to start your aviation training, then you will have some money to start your scuba diving, and then you will do some other parts, and then you will be very good astronaut candidate. But all of the other astronaut training is done because of the space agency is investing the money. And of course, your country is investing the money in you, right? So you have to be a healthy person. You have to have a very nice attitude towards the other people. You need to help the others, because this is very important. Astronauts is not only about flying to space. It's about education. It's about sharing your passion. It's about all those things which is connected to us together. Because if you're going to Mars, there's a 200 days this is the 200 days how to get to Mars. Then you are spending there half a year, and of course, because the planets change their orbit, you have like 1 year coming back, or you have to stay even longer. So the mission to Mars is like right now for 2 or 3 years long, right? Mission to Moon is relatively easy. It's like 3 days, one direction, and 3 days back, right? So you can stay week, 2, half a year. That's not a problem. 3 days and you're back. So ISS, 90 minutes, and you are in the completely different, and you are in your place, right? So it's completely not a problem. But the further we go, we need people who are stable nature, and they have very nice attitude towards each other. And this is very, very important. So you need to learn how to help each other and how to be a good person. This is very important. And then you add some more skills. And then on the astronaut selection committee, there are only 3 requirements right now. NASA, so I would say how what NASA's requirements are, but the other agencies have exactly the same, or very similar. So the first condition is to have 140/90 your blood pressure measured in the sitting position. So if you are not smoking, you are not drinking, you are good enough, right? So don't smoke and don't drink. This is the first thing. The second thing is to have eyesight which is 20/20, but you can have corrections. So you can have lenses, you can have glasses, you can have anything that gives you possibility to correct to 20/20. So this is also very nice. Well, if you don't have perfect eyes, that's also very good. Unless you want to be a pilot, unfortunately for the pilots you need to have better eyesight. But for engineer and scientist and medical doctor, it's not such a big deal. And the second requirement is to have at least a Bachelor of Science from natural science or engineering. And that's it. So you have those 3 requirements: blood pressure, eyesight, and some kind of education, right? Undergraduate education. It's not very sophisticated. But then you go to the selection committee, and you have people who are dedicated their own life towards being an astronaut and so on. So then you are standing on the selection committee, and next to you there's a 3 times war veteran. He's 26. I don't know how he made it, but he's a jet fighter pilot with 609 carrier landings, and he's also a medical doctor, and he speaks 10 languages, and you can find this kind of people, and especially in the selection, astronaut selection. So then your 140/90 in a sitting position, it's not good enough to beat this guy, right? So this is the reason why you have to prepare. And this is the reason why you are in the best place right now. So you need to educate, you need to focus, and you need to learn what to do in order to get to this point, to beat this kind of guys, right? To be better than them. So, because he can be a fighter pilot, but then you show that you have PhD, you excel in science, you excel in engineering, and you also a pilot. You're not a fighter pilot, but you're also a pilot. And because of your engineering and science career, they will prefer you. Because in the end, you are doing science and engineering, right? This is the most important. Okay, so together with Agata, we built Habitat. And this is a very important slide, but because we built this Habitat in Poland, which is very nice. And here I'm with Agata's father. And by build, I mean like literally build this Habitat from scratch, brick over brick. And we were bricklaying, putting a lot of plumbings, a lot of electricity, wiretapping, everything, like literally. I'm a computer scientist by profession and an aerospace engineer, but I learned how to create a home, how to create a shelter. And this is also very important. So whenever you go for this kind of journey towards the space, you need to learn how to come out from the safe place. So it's very nice because I always sit in front of the computer and I was doing my stuff, but then you have to create, build, you have to learn about new things, which you don't completely have no idea. So you take your books, you take stuff, and you build. The first version is not good enough. I mean, like the first version, it always it's a kind of failure. It's not it's not perfect. But then you iterate. The next year we improve the habitat, and it was very nice. And this year this habitat is even better. And the next year it will be very nice because it will have pressurized compartments, and we will do this kind of effects, which is saturation diving. And for the next year, we are planning also a habitat which is underwater. So for people to constantly live underwater. And you have completely different emergency situation because of the huge pressure. You cannot go out, like if there's a fire or something like that, you cannot go to the surface straight up because your nitrogen will burst your cells inside your body. And this is called DCS effect, or decompression sickness, or depends, right? If you are going to be a school library, you will learn about that. So this is all about, so iterating, getting better, and getting out of your safe place. Okay, we are conducting this kind of simulation. I was living in this habitat for around a month in total. So I met a couple of people, and we have different situation. Some of the situations was very nice, and some of the others were very, I would say, not very nice, and we had some kind of problems. And then you need to deal with that. You need to deal because you always encounter people you don't agree, right? And then you have to find your way how to work with them despite of all the division that you have. Of course, there's a lot of simulator flying. I was on this training course. So the first is from Soyuz capsule. So this is a Soyuz capsule simulator. The second one is a fighter jet simulator. And those two are very nice. So this is in the hyperbaric chamber. So they put you in the hyperbaric chamber. They pump out the pressure. So you have very low partial pressure of air. And you are having this crazy effect. So your body is oxygen deprived. And you start having this feeling of different kind of, like vision can change. You can have very narrow vision. And you can don't feel your fingers or something like that. And then you have to think and you have to recognize the effects, and then you need to fly your spacecraft, right? And then, of course, this is a very nice training course I took in the United States. It was about the flying suborbital flights. It was a research for noctilucent clouds, which are very high in the atmosphere. Nobody has ever done a research on that. It is like 73 kilometers above the ground. And then we are flying with the Virgin Galactic Spaceship 2 through those clouds, going to space, back again through the clouds and taking samples of the clouds, and then he records also the structure, and we have a lot of science going on. So you are dealing a lot with spacesuit operation, emergency situation, and you need to learn how do you conduct this kind of situation when you, for example, land in water. Because you can easily land in the water, but then because of the center of gravity, it will flip down, and then it will submerge. And you have to know how do you escape from this kind of structure before you're going to die. And you have like one breath to think about that. So you have like very well established protocol that you need to localize the emergency exit. You need to focus, you need to strap, then it's a hit. If you leave, because of course you will die with this, but of course if you leave, you need to remember what is the protocol. That you do not unstrap yourself. You have to feel, and you have to conquer your natural instinct to get out and trying to find out. Then you localize exit, that you remember, and you open it. Because if you're tumbling in the water, if you unbuckle yourself straight up, you will floating around the cabin, and you will never get to the emergency exit. So you have to conquer your natural instinct. And this is how you train that. You are training this by going underwater. Here's the breathing apparatus, but in this kind of trainers, we don't have breathing apparatus, and you are on your own. And you are submerging, flipping down, and going for 10 meters at most. And of course, if you survive, then you are in the middle of the ocean, right? So the ocean has a lot of salt water. You don't have food, you have only the saltifier, so you have this kind of small device which can produce water, and then you have to learn how to live on the ocean and wait for the survival. Of course, you have different equipment, but it can take in the most deserted places in Earth, it can take up until 72 hours when someone can lift you up. So you need to live for 3 days in full 42 degrees is nothing on the ocean, right? Because you don't have anything. It's very hot. The water is not working with you, and everybody is like tired, exhausted, and you live through the crash, and you have like morale is very low, so you need to live with and deal with how to deal with that. Yes, you need also to learn how to skydive. It's not my favorite thing, I would say, because whenever I'm going to skydive, I'm looking towards the earth. It's like I've done so many things, and wasting this. It's not a very good way to go. And then I jump, and when I'm flying on a parachute, it's okay. But this moment, like when you're standing in the doors of the plane, is like, what I'm doing? This is not the best way to go. Right? So, but you need to learn how to deal with your inner problems, and of course you need to know how to operate the suit, because with the suit you have a different problems. In suit you are breathing 100% oxygen, so you need to know how to purge that all the nitrogen out of your body. You need to learn how to deal with the different environment and different constraints that your suit is pushing towards you. So whenever I first had a suit, I don't have this picture here, but they struck me very well. I was like, something like that. And I said to them, maybe you can just loosen some time to that. You will see. And I said, yeah, but I cannot stand. Like, can you just help me out? And he said, you will see. And in suits, you have this thing here. On your gloves, you have this kind of straps here. They just make it so tight that I was not able to move my fingers. I was like, and you asked me to steer the spaceship with this, and he said, wait. And they plugged me in with the umbilical towards the oxygen source. They opened the oxygen, and then my spacesuit started to inflate. So it was something like that. And I was standing like that. The wrist was very good. You can have this, but that was very hard. And whenever you did this, and now I understand why they have this kind of straps on your gloves, because the pressure will make it's like bubbles, so you would not have fingers. You will have like one bubble. So the straps are making shape of it. Yeah, there's a lot of different effects that I didn't know about before this training. And of course, when you are also doing this kind of science, you want to learn about Earth, because it's all about Earth. So if we are going to go to Mars, we have these two things. The first thing is that we want to, like, there's a very nice saying that the asteroids are the question from universe, how's your space program going? Because dinosaurs didn't have the space program, right? So yeah, at least we should have the better answer for this question. Because they're kind of merciless, and every year we are encountering the objects between the Earth and the Moon, which is like flying by. And we're just living like here without even noticing this. But yeah, there might be some year that it will be a little bit closer than usually, right? And yeah, we shall have at least better answer than the dinosaurs had. So yes, this is the first thing. The second thing, we are doing a lot of advancement in medical studies, engineering, and so on. So we are using these technologies here on Earth to improve our life, to have better surgeries, to have. Yesterday, I was looking at the video on YouTube that's in Zurich, in Switzerland. They have created new ways how you can repair heart. They have this laparoscopic surgery, so they take like this straw that if you order a cocktail, you have straw. So they take this, they put this into your heart, and they have this small thing, not robots but mechanical things, which can repair your heart from inside. This is pretty cool, I would say. 5 years ago, you will die with this heart condition. Right now, you can live. And in 5 years, imagine what will happen. So this kind of advancement. So because you need to protect yourself from the radiation, so you need to find a way how to better deal with radiation, how to better store the energy, how to better store and have food, and to process water, to get the energy from different kind of sources. And this is very crucial, especially in the different countries, right? So you're doing also this kind of atmospheric science. And this is very nice because it's a GoPro camera which we put on the stratospheric balloon, and this balloon went straight up 30 kilometers, 30 kilometers up. And this is very nice. Earth is round. This is interesting. So then this picture is very nice because I don't know whether you can see this, but there are two lines here. Can you see this? What are these two lines? What do you think? These are the commercial jet planes, like normal airliners, which are 20 kilometers below. If you stand here and you will see jet plane, it is like 10 kilometers above. And we are 2 times higher than the jet planes, and we are looking down. This completely changes your perspective. And this is still 1/3 way to space, because space is around 100 kilometers away. And this is not even slightest in the way to ISS. It's 1/10. And how far is Moon? 385,000 kilometers, because it changes a little bit, but something like that. How many planets you can put between Earth and the Moon? How many planets? How many planets do we have? 8 or 9? 8. I know some people that still they don't believe that Pluto is not a planet, but yeah. Okay, so let's put all of the normal organisms. But the nice thing is, this is green tea, a little bit sweet green tea. So this kombucha thing give a lot of minerals and a lot of vitamins to this green tea, so you can drink it. But it has also very nice property. So if you take the Scooby, which is this part, you take this out, it regrows in 2 weeks. So you have a lot of very nice productive materials. So what Kata did, she discovered a method how you can produce the linen out of this. So she's producing the linen, and she's producing also small stripes in order to create your suits. She's targeting for the astronauts because 1 kilogram to the low Earth orbit right now costs $20,000 US. And we are bringing suits, we are bringing stuff, we are bringing clothes, everything to space. But after a while, if you discover this, and this will regrow, and you can learn how to create clothes out of these, you can regrow this, and you can lower the cost of the space travel. Like in this, but if there's 1,000 of different things that you mentioned, it will be lower and lower and lower. But there's another very nice effect. I told you that there is a lot of different bacteria, right? So there's another thing that we are working on with Agatha. So we change, bioengineer, we change the bacteria which is normally in this thing to the bacteria which produces the energy. The anaerobic, so they don't use oxygen, but they produce the energy. Like they are behaving like leaves. So they have light and they produce energy. And we are working on this, how you collect this energy in order to power up the sensors on your clothes. So you can have sensors on your clothes, and it could be powered up because you are wearing this. We are also investing in some our thinking into having the bacteria which will eat your dirt of your skin. So it will be like taking bath all of the time. So you'll have producing energy, you'll have sensors, and these sensors and this kind of shirt can be used, for example, for elderly people who can be monitored constantly, their heart condition, their lungs condition, and if there's some kind of problem. If there's a heart attack or something like that, they can be, the ambulance could be just called in a second. And this kind of technology, this kind of advancement, this kind of thinking, because we need this technology for getting to Mars. But this has amazing application for your image. Another question?
Good afternoon, sir. So, actually, my question was actually about the growing of plants on the ISS and about the watering of plants. So, if we straight water them like this, because due to the absence of gravity, the water will flow out. And if we inject the water directly to its roots, the water would surround the roots and they would dry up. So how do we water the plant?
Ah, that's a very nice question. So the first thing, if you inject water, it will not go up because it will have the same motion because it will not stop. It will not go up because there's no notion of up, right? So this is the first thing. But yes, this question is very good because if you pour this water to the roots, you still need oxygen delivered to the roots. And this is the reason why, together with Agata, I had this on my second presentation, but I can show you a glimpse of this. Let's have this presentation. This was, I think this is the... So on this presentation, there's a different experiments that we were doing, and so on. The last question, but I can talk about it. So, yes, my favorite programming language is Python. Python. Language Python. So, and I have wrote a book about Python. It's since the very early beginning. Like, you have never programmed and you can start using this book up until machine learning, artificial intelligence, and this kind of usage. So Python is an amazing language, and more agencies and universities embrace Python. And Python starts to emerge as a lingua franca for the all scientific, engineering, and all the fields where your main goal is not to create software. Java is very strong, and I consider myself as a software engineer. So I use tool which is the best for solving problems. If there's a problem with high availability, I would use Java. If there's a problem for creating small application, I will use some scripting languages. If there's a need for creating low-level code, I will use C or assembly. If there is a need for creating artificial intelligence and machine learning algorithms, I will use Python because this is the most common language for that. Yes. And for the Arduino boards, oh, this is very nice. So I program. So I had the sensors. By the way, from this hydroponics. So I have get all the sensors like relative humidity, like lighting condition, temperature, moisture, and you have also flow sensor, pump sensor. You have because you have outside like how the plants are behaving, and you have also inside the tubes. Because you have tubes with flowing, so you need also this kind of things, and concentration of the nutrients in the water. So you have different ways, right? Because of the conductivity. So I created this, and I connected everything to an Arduino board, and I created a small driver in C, in language C, which produces the JSON format data, which this is also connected via USB to Raspberry Pi. So this gives the information in JSON, and in this thing there is a small program which is going in the loop. It takes the data in JSON format because JSON is pretty easy to parse in Python. So it takes this thing, it saves the database, and then when there is an internet connection, it pushes to the operation system that I wrote, also in Python by the way, to this Habitat OS. So this is a extraterrestrial habitation operating system, which gets all the data from the different sensors in the habitat. It takes from your body measurement things when you go outside for the EVA. It also takes, it gets hundreds of different data from the different standpoints, and it connects to one.
Artificial intelligence is working with this.
How the artificial intelligence is working with this? So if you have hundreds of different data, and we have data about behavior of the people. So, sorry, but I like this topic. So I will show you.